Okay, I'm going to talk about amplitude modulation. Okay, its concept is very simple. Okay, concept is very simple. I told you in my previous class that if you want to transmit a signal, okay, for a long distance, it is transmitted through a carrier wave. It is transmitted through a carrier wave. Okay. And I also told you that this carrier wave is of high frequency. And why we need to have a high frequency carrier wave, I also told you, right? So that your antenna height will be reduced from kilometers to meters, right? The signal, the message signal, if we consider our voice signal, okay, is of low frequency in nature, right? That's why we are going to transmit that message signal through a high frequency carrier, right? So now can you tell me, to transmit a message signal, now how many signals are required for me now? How many signals are required for me? 2 signals, right? One is the signal itself, another one is the carrier signal. Have you understood this? Okay, is it fine? Okay. Now, I think I have also told you that what you are transmitting is a carrier wave, right? But your carrier wave has information of the message signal in it. Where? Okay, where it is? Okay, that is in the amplitude of the carrier wave. If I vary the amplitude of the carrier wave according to the message signal and transmit that signal, right? Your purpose is solved, yes or no? One purpose is that you are actually transmitting high frequency signal only. Along with that high frequency signal, which is carrier, you are also transmitting your signal. Where the signal is sitting? In the amplitude of the carrier wave. Yes. I've understood this. Okay. That is what called as amplitude modulation. Right? That is called as amplitude modulation. Why it is called amplitude modulation? Don't worry about this. You can write it later. I'm going to give the slides to you, free of cost. Okay? Right? Right? Just try to understand this. Okay. Right? Now, have you understood what is amplitude modulation? Right? In amplitude modulation, amplitude of the carrier wave, okay, is varied according to the instantaneous value of the message signal. Right? Okay. Just let us check here. I'll go to this calculations later. Can you see this? Okay, I'll just. Don't worry. I'll just use the board. Okay, let this be, this one, see, let this be your message signal, okay? I'm not drawing it according to the scale. Later, you can do it in MATLAB, you can see everything properly. This is the message signal, okay? So I will write it as, this signal as m of t. This signal as m of t. Fine? This is a low frequency, right? Okay. Now, I will draw the carrier signal here. This is the carrier signal. I will represent it as C of t. Right? Okay. You need not always stick to only same nomenclature m of t, c of t, doesn't matter. This is just naming the signal, that's all. Okay, fine. Because I'm calling this as a message signal, I'm putting it as m of t. Because I'm calling this as a carrier signal, I'm putting it as a c of t. That is the only purpose. Okay, of putting m and c there. Okay, you can put a and b also, doesn't matter. Okay. Now I will draw high frequency wave, carrier wave with constant amplitude. See, this is your high frequency wave. This is called as carrier wave. Sorry, frequency remains same. Okay, if at all you see different waves here, just pardon me. Okay, it should be same frequency. I can't draw it exactly to the scale. I'll show you using MATLAB. Don't worry. Okay, this is your carrier signal. Okay. Now, this is what transmitted. This is not transmitted. You are transmitting only carrier signal. Right. Now, before transmission, this carrier signal has a constant amplitude, right? Let the amplitude of this be AC. Let amplitude of this be AM. You can give VC and VM also, doesn't matter. Okay. Fine. Okay. Understood this. Now, this signal is transmitted. Right. Now, we cannot transmit this signal as it is, but this has to carry this. Right. So, what is done? The amplitude of this, okay, is varied according to the instantaneous value of this signal. Right. So, how exactly it looks after modulation? If you vary the amplitude of the signal according amplitude of the carrier wave according to this. Okay. Just for the scale, I'm just drawing dotted version of this message signal. Okay. Just dotted version. Try to make it as for the scale as possible. Okay, see. Okay, fine. I'll just write dotted one just to exactly it should be like this. Suppose this is your base. From bottom side also. Okay, fine. Okay, this dot, it is just to draw the scale because I have to vary the amplitude of the carrier wave according to this instantaneous value. That's why I drawn this. Okay, your waveform is exactly your modulated waveform will look like this. Your modulated waveform will look like this. See, amplitude of this will be varied. See here. See, this amplitude here like this. See. The green one, what you see, is modulated carrier wave. Okay, it should be. Okay, yeah, I'll just drop you here only. Okay. Can you see what's happening here? amplitude of the carrier wave, frequency remains same, right? Suppose the frequency of this, wave, let it be m hertz. Okay, let the frequency of this wave will be fc hertz, carrier wave fc hertz. Now frequency of this is called as amplitude modulated wave. This is AM wave. It is amplitude modulated wave. Yes, in FM, amplitude remains same, frequency will vary. In this case, amplitude will vary, frequency remains same, right? So amplitude modulated wave. Now, how do you recover the original signal in the receiver? Just pick this, all the peaks. If you can have a circuit which can take only the peaks of this carrier wave, that is going to give you original signal. Yes or no? Have you understood this? Right. If you pick the peaks, take only the peaks of this. See, this blue color. Take only peaks of this signal. Now, can you tell me what is this? This is the original signal. So at the receiver, take only the peak of this. You get the original signal. Have you understood this? This is called as amplitude modulation. Have you understood about amplitude modulation? Right? You want me to repeat this? Okay, listen carefully. This is your message signal. Okay? Message signal, all of you know, it's a voice signal. Okay? And it's of low frequency. Right? Okay. Now, this signal, what you see here, is a carrier signal. Right? It's a carrier signal. Why it is called as carrier signal? Because that is the signal which is carrying this message signal. Right? Where it is going to keep the message signal? In its amplitude. How it is keeping? See, the amplitude of the carrier wave before modulation is constant. Frequency also constant. Right? Now, in amplitude modulation, we will try to exploit the amplitude of the carrier wave. What we will do with the amplitude? We will vary the amplitude of the carrier wave according to the instantaneous value of the message signal. See here. This is the carrier wave. The amplitude at this point is varied according to the instantaneous value. What is the instantaneous value here? This one, right? Now see here. See here. Till here it is varied. Right? There is one fixed amplitude. Okay, this one, there is one fixed amplitude called as VC. Okay, this AC is used. Okay, right? This signal amplitude is varied with respect to one reference, that is your AC. Right? So from here, see how much it is varied? Till here, see, till here. Next, till here. Next, till here, till here. You can see that amplitude of the carrier wave is varied according to what? According to message signal. Instantaneous value of the message signal. Why I am just stressing here instantaneous value? Because this peak is varied according to the instantaneous value. This is the instantaneous value, right? This is the instantaneous value. This is the instantaneous value. It's instantaneous. You can see every peak of this are varied according to the instantaneous value of message signal. So this waveform what you see here is called as amplitude modulated wave. This is not transmitted. Whatever AM wave you are coming across, it is like this only. Have you understood this? Right? Now, have you understood definition of amplitude modulation? What is called as AM wave. Have you understood this? Okay. Now, the idea behind the receiver to receive the original signal is just take the peaks of this. Yes or no? Just take only peaks. If you just collect only peak information of this carrier wave, which is transmitted, what you get? You get the original signal. Yes or no? Have you understood this? Okay. Yeah. Same thing. Same wave. Now, I'm going to tell you about frequency modulation. Now, in frequency modulation, the amplitude of this carrier remains same, but frequency, instantaneous frequency, is varied according to the amplitude of this. So, at this instant, frequency of the carrier wave is equal to this value. At this point, frequency of the carrier wave will be equal to this value. Right. So at this point, okay. So at this point, frequency of this carrier wave will be equal to this one, like this. Yes or no? So where lies your message in carrier wave in frequency modulation? In frequency. There is something called as voltage to frequency converter available in the electronic circuits. You can convert voltage variation to frequency variation. Have you understood this? Right? Voltage variation to frequency variation, which is called as voltage controlled oscillator. Which is called as voltage controlled oscillator. That is what done in the frequency modulation. Yes or no? Right? Voltage controlled oscillator. Okay. We will come across that whenever we do frequency modulation. Right? That is FM. Right? There are a lot of benefits of FM compared to AM. We'll see that. Why FM is most popular than AM. So while comparing both AM and FM, we will see why FM is better than AM. Fine. Okay. Now let us spend a couple of days with the amplitude modulation. Fine. So you have got the idea of amplitude modulation, yes or no? Fine. Paka? Sakshi? Understood? I will go to ask question at the end of the class. Have you checked your handouts? How many of you checked your handouts? In evaluation components, I said classroom tutorial, classroom questionnaire. Right? Okay. I'm going to ask very simple questions. Okay. You should answer. Okay. Fine. How to get this wave? How to represent this waveform mathematically? See, especially in engineering, right? Mathematics always come into picture. Okay, that's why your first 2 years in BIT learning, you are having so many mathematics, so many science, etc. Right? Now we have to represent this equation, okay, with a function, Yes or no? See, what exactly you're doing here? What exactly you're doing? You are actually, this is the output of a transmitter. This is going to be output of a transmitter. Yes or no? Right. So you have, see, this is your system. Input is a message signal. Output is a modulated wave. Okay. Let us see. It is represented as SAM of t. SAM of t. Right. it is making use of a carrier wave inside it. Right. So what you're going to supply is the carrier wave to this. Okay. The oscillator. And what you get is a AM wave. This is your transmitter. And what you do in a transmitter? What you do in the transmitter? Don't go too much. Simple, tell me. Huh? Now, what you are doing in transmitter? I just want one word answer.
Transmitting the signal.
Modulation. You do modulation, right or no? You just do modulation. In amplitude modulation, you do AM. That's what you do in transmitter. Right? Have you understood this? Okay. Now, we need to represent this output in mathematical form. Right? Okay. Similarly, input, if I take this sinusoidal wave, you know how to represent sinusoidal wave, right? How do you represent this? AC, cos or sine, okay. Cos omega mt. Can you name this signal using a mathematical function? This is equal to m of t is equal to am cos omega mt or am cos 2 pi f m into t. Right, okay. This also same, yes or no? Either cos or sine, doesn't matter. Right, I understood this. Okay, now let us write the equation for AM modulated wave. Can you tell me what is done in AM? I'm asking same thing what I taught you. Amplitude of the carrier wave is varied according to the instantaneous value of the fine. Okay. Now look at this definition. See, let m of t is equal to am into cos omega mt. You understood this? Okay. C of t is equal to AC cos omega ct. Fine. Now, after modulation, what will happen to AC? AC will vary according to m of t, yes or no? Yes or no? Tell me. Now, you replace AC by AC plus m of t to get a AM wave, yes or no? Yes or no? Okay. Now, can you write the equation? It's very easy, yes or no? See here. AC plus m of t into cos omega ct. Substitute m of t here. Okay, little trigonometric simplification. Can you do this trigonometric simplification? Substitute am cos omega mt into cos omega ct. See what you will get. Take AC outside. Take AC outside. When you take AC outside from here, you will get 1 plus am by AC cos omega mt into cos omega c. Replace AC by am by AC as a m, small m. It's just a factor, multiplication factor. And there is a very good importance for that m. We call it as a modulation index. We call it as a modulation index. Understood this? See, I think you understood till this point, right? So what is done in the next step is AC is taken outside. When you take AC outside, you will get 1 plus am by AC cos omega mt in cos omega c. And this replace that am by AC as m, where am by AC is called as modulation index. Modulation index. Fine? Okay. Now, can you simplify this? Just simplify this. Just simplification. Right? Just simplification. I will tell you about it. Because I was talking about Fourier transform pairs, right? I was talking about Fourier transform pairs. Right, okay. I'll tell you about it, don't worry. Right now, you just try to get this equation. Have you understood this equation? Okay. Don't leave it as it is here. Okay. Can you just tell something about this equation? What are the components of AM wave? Look at the equation, what it has. Look at every component of that. Look at every component of that. What it has. See, just simply don't leave the equation. When mathematics come to the engineering, okay, it has a lot of meaning. Right? In your first year, second year, the mathematics is, it doesn't mean to any engineering aspects. Right? Now you see here. Can you see what is there in this? It consists of one carrier in that, yes or no? It consists of AC cos omega CT. What is AC cos omega CT? Carrier. And also, it consists of two components. MAC by 2, omega C plus omega M. MAC by 2, omega C minus omega M. Right. Now tell me, how many frequency components are there in AM wave?
2.
How many said 2?
3.
How many said 3? Lift your hand. You're all 2 or 3? 3. Right? How many said 2? 2. Which are those 2? Tell me. Huh? See the equation. What's the frequency component? You have omega C.
Omega C plus
you have omega C plus omega M. You also have omega C minus omega M in this particular equation. There are 3 frequencies exist in this. Right, have understood this. Now, what is omega for AC cos omega CT? Carrier wave. Right? It's a carrier wave, all of you know it. What is cos omega C plus omega M? That is omega C plus omega M. Omega C plus omega M is called as upper side band. It's called upper side band. It's called as frequency band. Upper side band frequency. Upper side band frequency. Omega C minus omega M is called as lower side band frequency. Lower side band frequency. This is the frequency component of the AM wave. Right? This is the frequency components you get. Yeah. You have omega C plus omega M, omega C minus omega M. Why I am telling you this? Because you need to know the spectrum of the AM wave. You need to know spectrum of the AM wave. Suppose if I ask you to draw the spectrum of this AM wave, what you will do? Tell me. You will have to take the Fourier transform of this. Suppose if I ask you to take the Fourier transform of this equation, how you will do it? Tell me. I want to take the Fourier transform of this equation. How will you do it? I am giving you only 2 minutes, 1 minute of time. How you will do it? Will you start something like this? Will you start like this? Integration minus infinity to plus infinity. Write this equation dt. Of course, that is the equation. But if you just start writing and solving this, how much time is required for you? How much time? That means you need to know the Fourier transform pairs. Right? You need to know what is the Fourier transform for sin theta. Right? I've understood this. See here. the Fourier transform of cos omega ct, okay, is equal to pi into delta omega minus omega c plus delta omega plus omega c. What is the delta there? Delta function. Hope all of you know about delta function, right? Impulse. All of you know about impulse with delta function, right? Okay. Now plus, see here, plus MAC by 2 already it is there. Fourier transform of this, that is delta omega minus omega c plus omega m, delta omega plus omega c plus omega m, right? Similarly, MAC by 2 anyway it is there, pi into delta omega minus omega c minus omega plus delta omega plus omega c minus omega. Hope all of you understood how I got this equation, right? It is just a Fourier transform of this, and best way of getting this is knowing the Fourier transform pairs. You should know what is the Fourier transform of psi omega ct. Have you understood this? Okay. Now can you draw this? Can you draw this? Can you draw, my dear Arjun? I will not go to next slide now. I want you to draw this. Just draw this. That is going to be the spectrum of EM wave. Right? That is going to be the spectrum of EM wave. Can you please draw this? I'm just asking you, just draw this. You know what is delta function, right? What is delta? Impulse.
1 for
Impulse
t
means
equal
come
to
out.
2. And
In Hindi, come out. Okay? Yeah. Right. With some amplitude of the come out, right? So what is the amplitude for delta omega minus omega c? Is it only AC? Pi AC. Right? What is the amplitude for delta omega plus omega AC for this? Also pi AC. Okay. Now can you draw this? Can you draw? Do it. Draw. I will show it in the next slide, but you have to draw it. It's very easy. So how many khambas will come when you draw? How many total number of khambas?
6, sir.
How many frequencies are that much khamba will come? 6. Exactly 6. Exactly 6. Anyone has drawn it? Why I'm telling you to draw? Because if you make a practice of drawing spectrum for this type of equation, you can easily do it. Getting sleep touches. Fine. Okay. Draw. I'll just give you 2 minutes. Draw the spectrum. Draw this. This is called as spectrum of EM wave. This is time domain. Okay. This one is frequency domain. Right? Okay. See, this one is time domain representation. This is frequency domain representation. Okay. So if you want to get this, you have to take Fourier transform of this. If you know Fourier transform pair, you will easily able to get the. Okay. Got it? See, this is what you are supposed to get. Right? There is one khamba at omega c. See, there is one khamba at omega c. Omega c, you have delta omega. What is omega minus omega c? Omega plus omega c? Shifting property, shifting of signals. Then omega is x-axis. That's what I told you. Spectrum in the x-axis you will have omega or f. Right? Definitely. What is the height for this? Pi AC. What is the height for this? Pi by 2 AC. Now, say this. Why it is taller? Depending, okay, m will be always less than 1. One thing you remember. This m value, okay, I will tell you this m value, okay, which is omega m by am by AC, that will be always less than 1. Why it is less than 1? Because this amplitude, see, this amplitude should be greater than this. If this amplitude is not greater than this, what happens when it comes here? It will go down. Because that's why your AC has to be always greater than AM. So m value will be definitely less than 1. So definitely your the delta of impulse will be less than this. Amplitude of this will be pi m AC by 2. Amplitude of this will be pi AC, which is very well seen from this equation. M less than 1. See here. Can you see here? This is AC, right? This is AM, right? Suppose this AC is less than AM. What happens? This will go and touch down here. It should not touch down here. It can touch, but should not go down. That's why we make this AC greater than AM. When you make AC greater than AM, okay, always this, you can make even AC equal to AM, okay, right? But not, okay. Otherwise, this will go down. It will become like this. This will become like this, right? It will become like this, which you call it as under modulation. That should not happen. Okay, you will not be able to recover the peaks if it happens like this, right? We will see that 3 cases of modulation. How many of you have done M modulation in lab? You have done 3 cases of modulation, right? M value is equal to 0, M value equal to 1, M value equal to 0.5. You have done it, right? And you have seen that under modulation, over modulation. Okay, always your modulation index is less than 1, not less than equal to 1, less than 1. Yeah, that's also not good. On the border, okay. So those who